Let's take a few minutes to discuss alkyne nomenclature. And the rules are going to be very similar to that of naming alkenes. Mainly the multiple bond must be part of the longest chain, even if that means there's a potential to have a different longest chain that's even longer. You exclude that one. The multiple bond needs to be part of the long chain, the parent chain. And we number so that the multiple bond gets the lowest possible number. So in that case, that means we have to number this one from the right side. And that gives us a non-ine. So instead of ane or ene, we use yne to denote that there is a triple bond present. And in this case, it's 4-non-ine. You may also use non-4-ine. That is the modern rules of IUPAC. I prefer this one, but again, I'll certainly accept that one because it falls within the new rules as dictated by IUPAC. And lastly, we have these two methyls here at carbon 6, so it's 6,6,4-non-ine. I'm sorry, it's 6,6-dimethyl. And that's it. There's no stereochemistry associated with a triple bond, of course, and there are no other stereocenters present on this alkyne. Let's look at one more. We don't want to spend too much time working on these, but it is important to at least be able to name them in a relatively straightforward manner. So again, the longest chain must contain the alkyne, and that means that our numbering scheme goes like this. Even though we have 3 carbons over here and I could draw a 7-carbon parent chain, I must include the alkyne as part of my main chain. And I have 2 stereocenters, so let's go ahead and assign configuration to both of those. If we're looking at carbon 3, we have 3 carbon groups that are attached to carbon 3. If we think about what those carbon groups are made of, we have those. So those are our lists of what is attached to those carbon groups. And so the chlorine here gets highest priority, so that should be the number 1. Number 2 is the alkyne, number 3 is the propyl group, and number 4 is this hydrogen. I'll put that in here, we don't have to. And so that gives us a clockwise rotation, but again the hydrogen's in the front, so it should really be counterclockwise. This is S, so we have a 3S, and we have 4, which we're going to establish right now. So this is also a stereocenter. The chlorine is the highest priority group. And then we have to choose between the carbon here, carbon number 3 on the chain that is attached to 2 additional carbons, or carbon 5, which is attached to 3 additional carbons. So that's going to be the second highest priority, and then carbon 3. So if we count like this, 1, 2, 3, that gives us clockwise. The hydrogen is in the correct position, so we have 3s, 4r. And then we have some substituents here. We have a 3 propyl. I have a 4 chloro. And I have a 5,5 dimethyl. And lastly, I have hexyne. And I have 1 hexyne because my alkyne is at the front, is at the first carbon. So I put these in order. C, then M, then P. So 3s, 4r, 4 chloro. Then the dimethyl, 5,5 dimethyl, 3 propyl, 1 hexyne. So you can see how these names can get pretty complicated, but again, they allow us to be absolutely sure which molecule we're talking about, and every single possible isomer will get a different name. So this is just simple nomenclature of alkynes.